Now, we can put all these things together to solve basically every single variable algebraic expression we're going to get, again with the exception of functions, which we'll talk about a little bit later. But the idea is, say you are presented here, as you can see on the right-hand side, with an equation that involves multiple operations at a time. And let's say that your goal here is to solve for x. So you want to get x by itself so you know what it's equal to. Now what we talked about previously is the most efficient way to do this is to take a look at the variable you want to find, and you want to get rid of all the other numbers in order from least complex, so down here at the bottom, to most complex up here at the top. So if you take a look at this thing, we have multiplication, we have powers, we have more multiplication, we have brackets, right? We have the whole bit. However, the simplest operation, that is with x on the same side of the equation, is actually addition, because we're going to start at the bottom of order of operations. Now, to get rid of this, what we're going to do is we're going to use an inverse operation. So what we're going to do to both sides is instead of adding 15, we're going to subtract 15. And this is basically going to cancel out our addition that we're trying to get rid of on the left-hand side here. And on the right-hand side, we can evaluate 25 minus 15 is equal to 10. Now, once we've rewritten this, we're going to proceed with the next one. What you'll notice is the next thing that actually shows up is the multiplication by 6. It's outside of the brackets, so it's the next step up. So what we need to do is we need to evaluate or get rid of this multiplication by 6. Right? It's our second level of complexity. So what we're going to do here is we're going to divide each side by 6. Just like before, on the left-hand side, it's going to cancel out the multiplication by 6, and we can simply evaluate 10 divided by 6 on the other side. If you want, you can even convert it into a decimal. Now, once we've done this, again, we're just going to work our way up the order of operations. The next thing that we see outside the bracket is this exponent of 3 that is present here, which I'll underline in green. Now, this is an exponent here, so to get rid of it, we're going to find the inverse exponent. To do so, we're going to find the actual power we need by taking 1 and dividing it by the exponent that we want to get rid of. So basically, the exponent that we need to apply to both sides is simply 1/3, which is approximately equal to 0.33. And what we're going to do is we're going to apply that to both sides. So on this side, we're going to add an exponent of 1/3 to the entire thing, which is why the green pair of brackets exist. And on this side, we're going to apply the exponent of 1/3 to the entire thing. 1.67 to the 1/3 again is just going to yield us a number. And on the left-hand side, the exponents are going to disappear. This will also allow us to remove the brackets, because as long as there's nothing outside the brackets, they don't do anything. And with that, we've done all of our order of operations up to brackets. Now, we still don't have x by itself, so we're just going to, again, repeat the process with the brackets removed. So I'm going to move this up to the top so we have some more space to work. And again, our goal here is to get x by itself. So one thing that you'll notice here is we do need x by itself in the numerator. So how you do this is up to you. You can either divide both sides by 2, but what I'm instead going to do is I'm going to rearrange this slightly so that x is by itself in the numerator. Typically speaking, that is the easiest way to deal with this. How you would do this is just like you can remove a division by 2 by multiplying by 2. You can remove a division by x here by multiplying each side by x. Right, and what this will do on the left-hand side here is it will cancel out the x that we had in the denominator, which was causing us problems. This lets us rewrite our equation with 2 is equal to 1.186 times x. And now that we're here, again, our goal is still to get x by itself. So what we're going to want to do is we're going to want to remove the coefficient that is with x. So we're going to want to take each side, and we're going to want to divide the entire sides by 1.86. Just like before, it's the only operation for us to get rid of. On the right-hand side here, the numbers will cancel out, leaving us with just the x that we wanted to find. So we will just have x on the right-hand side. And on the left-hand side, all you really need to do here is take 2 and divide it by 1.86. And that will give you the answer that you're looking for.